In the 1970s, astronomers are stunned. Some unknown form of matter, invisible to telescopes, dwarfs what we thought was out there. Not a fraction more, but 5 times more.
We used to think that gravity came from stars and objects you can see. End of story. Now we realize that that naive picture is actually wrong.
Astronomers make the discovery, studying the clockwork nature of our universe. The huge gravity of the sun holds the Earth and all the other planets in a delicate circular dance. The sun's mass controls the speed of these orbits. If it were more massive, the planets would orbit much more quickly. If it were smaller, it would take much longer for a planet to complete an orbit. Galaxies run like clockwork too. The vast mass at the center pulls the outer stars into circular planet-like orbits. Astronomers make precise measurements of these galactic orbits in the 1970s. The results change everything. The galaxies were spinning too fast, way too fast. Even accounting for the supermassive black holes at their center, 9/10 of their mass was missing.
By rights, the galaxy should fly apart. By rights, the Earth should have been flung into intergalactic space billions of years ago. We should have no Milky Way galaxy, and yet our universe is full of galaxies.
An immense additional source of gravity must be holding galaxies together. But no matter where astronomers point their telescopes, they see nothing. Not a glimmer, not a shadow. Whatever this new stuff is, it doesn't emit light, reflect light, or even block light. They call it dark matter.
What we've learned is that most of the matter in the universe is not ordinary stuff. It's not atoms. It's not particles we've yet detected in any experiment done here on Earth. It's some new kind of particle that we call the dark matter.
Dark matter fills the universe, outstripping normal matter by 5 to 1. Vast filaments spread out throughout the cosmos. And bright galaxies cluster where dark matter is thickest.
Dark matter provides the scaffolding that underlies how the matter in the universe structures itself, where it goes, and what it does.
So dark matter dictated how the universe unfolded.
It seems as if, out of the hot Big Bang, dark matter condensed first, before atoms, and dark matter began to become clumpy. The clumpiness then began to attract atoms as they were formed later, and that formed galaxies.
And in some sense, the dark matter therefore provides kind of a womb that allows the birth of our galaxy.
Dark matter holds the universe together, but it also threatens to destroy it.
One of the most amazing discoveries of the past few decades is dark matter. The fact that there's much more matter in the universe than we were aware of. And all of that matter has a lot of gravity. So all this new matter, all this new gravity must be slowing down the expansion of the universe.
Dark matter may even tip the cosmic scales in favor of gravity, defeating expansion and pulling the entire universe towards a death by fire. It's called the Big Crunch. And this is how it would play out. For a fraction of a second, the universe stalls, poised between expansion and contraction. Then, gravity kicks off a cataclysm.
When you looked out, the very first things as it began to turn around that you begin to see is that galaxies, instead of moving away from us on average, would begin to be moving towards us on average. The whole universe would look like it was coming to get us.
As space contracts further, the density of matter increases. Gravity gets stronger. Temperatures soar as the crunch gathers momentum.
galaxies begin to collide, gas clouds begin to collide, planets slam into the Earth. Black holes will execute a death dance around each other. Temperatures, of course, will continue to skyrocket.
Matter, space, and time implodes until everything in the universe is compressed into a tiny speck of infinite mass, heat, and pressure.
For the last stages of the Big Crunch, galaxies will collide and form a primordial atom. And then life as we know it will be impossible.
We're back to where it all began, back at the Big Bang. The universe that we live in will cease to exist. But some believe a Big Crunch could herald a new beginning.
We don't know what the endpoint of a Big Crunch would be because the laws of physics break down. It's possible, and indeed philosophically very pleasant, to imagine that that crunch would somehow end up evolving into an expansion again, and you could have a cyclic universe which goes on forever.
Perhaps at that point, we will recreate another Big Bang.
It's conceivable that as everything comes together in the crunch, something sort of keeps it from just continuing and pushes out in a hot, dense, smooth state. And from the other side, it looks like a Big Bang and a new universe has been created. Our Big Bang might have been someone else's Big Crunch.
But when scientists came to terms with dark matter's Big Crunch, the universe threw them another, bigger curve. Some ghostly force seemed to be sending us hurtling toward a completely different death.
My postdoctoral scholar showed me the results. I nearly fell off my chair.
Gravity and expansion battle for control of our universe for 14 billion years. Expansion pushing it outwards. Gravity pulling it in. With dark matter in its corner, gravity seemed to be the inevitable winner. The extra mass will drag the universe into a big crunch, until a stunning discovery revolutionizes our understanding of the universe.
Around 1990, two teams of researchers decided to measure the expansion history of the universe to determine whether it's been slowing down so much that it'll eventually have a big crunch, or whether it hasn't been slowing down much and will eternally expand.
Astronomer Alex Filippenko was on one team. Saul Perlmutter led the other.
We realized that it was possible for the first time to go and actually make a direct measurement of how much the universe had been slowing down in the past.
Both teams want to measure the speed of distant galaxies, but because the galaxies are too dim and far away, they look for something brighter. Billions of light years from Earth, a star detonates. This is a supernova, a dying star's brilliant final gasp. It burns brightly, 5 billion times brighter than the sun, and briefly. Perlmutter and Filippenko have a window of just 1 or 2 weeks to measure how much the galaxy it sits in is slowing down as it moves away from us. The teams look for supernovae for 8 years. They measure 42, and the results seem impossible.
We plotted the points on the graphs, and it didn't make any sense. They were not slowing down at all. They were actually speeding up.
What both groups found stunned the world. In the last 4 or 5 billion years, the universe has actually been speeding up in its expansion, an accelerating universe, propelled by something mysterious.
For so long, we've been arguing whether the universe would expand forever or collapse back in on itself, but nobody thought the answer was going to be that the universe was accelerating, going faster and faster all the time.
The acceleration bewilders scientists. It seems to defy the laws of physics.
Imagine I've got a baseball and I throw it straight up. And instead of slowing down once it leaves my hand, which is what normally it will do, it begins to slow down at first, but then it starts speeding away. Somehow it's getting energy.
The new energy seemed to be coming from nothing, the vacuum of space.
The word vacuum to a scientist means completely empty space, no particles there at all, no temperature, no energy to speak of. But there's an intrinsic energy in space and time.
Empty space has energy, and that energy produces a gravitational repulsion, a kind of anti-gravity.
Without a clue what this force is or how it works, all scientists can do is give it a name: dark energy.
We could have called it we don't know energy. We could have called it anything, but we don't know what it is, and dark or not, it's the biggest mystery in physics.